last but not least, for our final demo, we're going to see one of the latest robots and discuss its potential applications on the battlefield. Please welcome Ghost Robotics CEO Gavin Kenneally. What's up?
Hi, Colin.
Please take a seat. So Hans just kind of spoiled the surprise, maybe, but there's something backstage. We have a friend joining us. What should we expect here in the next maybe 30 seconds?
Yeah, so this is the Vision 60 legged robot.
You can hear him coming.
You can hear it. It's on its way. We call it a QUGV, so it's a quadrupedal, uncrewed ground vehicle. So I'll give you a little bit of the highlight, maybe, some of the features of the robots. All right, so as you can see, the robot has 4 legs. So legs are a phenomenal way to get over all kinds of different rough terrain. We have legs. We're able to move around really well. Wheels and tracks often get stuck in all kinds of different environments. 4 legs means more endurance, more payload. So the robot can walk continuously for about 3 hours on a charge. It can carry about a 20-pound payload. It's full of sensors. So there's cameras at the front, microphones, speakers, lights at the front, sensors all the way around. And the robots are always trying to maintain their balance through some of our software algorithms. So you can see if I kind of push down on the robot springs right back up. It's kind of responsive and lifelike. There are no mechanical springs in the system. It's all going on through software. So that was one of our big innovations, is pushing a lot of the complexity from the hardware into the software. It's also always maintaining its balance. So I can kind of drag and move the robot around, and it's going to continue to step and maintain its balance so that it can continue to finish the mission and make progress. I'm not going to do it here, but if you take my word for it, if I were to kick the robot and flip it over, it actually will get up upside down and continue to make progress.
We can do that.
But maybe not on the stage.
No. It probably behaves better than my dogs at home, so
yeah.
I can respect that. How are you guys thinking through man-unmanned teaming, human-machine integrated formations? Like I said, performs better than my dog at home.
Robot, dogs sit.
Dogs sit,
well,
stay, come, bark, all of them. How are you thinking through man-unmanned teaming?
Yeah, so our North Star with the robot is really, how do we assist the warfighter? How do we prevent them from going into dangerous environments? So there's 2 main types of use cases for our systems. The first is persistent. So persistent meaning the robot actually goes and does relatively similarly things day in, day out. It's actually a dual-use product. So on the industrial side, that could be something like inspection of an oil and gas facility, making sure that nothing is overheating or going awry. On the defense side, it would be something like a perimeter security. So the robot consistently doing that, consistently kind of maintaining that secure perimeter and helping our airmen and airwomen. The other big use case is ad hoc. So these are more kind of one-off missions where the main goal is increase the standoff distance between the warfighter and some kind of source of danger. So it could be EOD, explosive ordnance disposal, CBRN, chemical, biological, and radiation and nuclear threat detection. So we have all kinds of different accessories and sensors that we can attach onto the top of the robot through this interface that we've designed, such that you can expand the capabilities and detect all of these dangers, do ISR with the robot, attach all kinds of cameras and other sensors, such that you're putting the robot out in these really dangerous environments and keeping the humans further back. That's really our guiding principle.
Before the event kicked off today, you mentioned something about marsupials. How does that tie into a robot dog?
Absolutely. So that's as we continue to scale up the abilities of the robots on their own, a question that we get asked all the time is, okay, how do we get these systems into theater? And one of the ways to do that is actually kind of this marsupial concept, where you would have a larger vehicle and you would actually have robots deployed on the side of the vehicle. They're inside and they come out. And basically, you can do ISR and you can kind of extend the ability to do, for these vehicles to do missions by having legged robots. So one example is, you have something like a tank column, rough terrain. The tanks are able to really move around over rough terrain quite well in unstructured environments. But if you get into a bit more dense urban environment, there's all kinds of impediments to motion Well, let's send up robots out ahead to do basically scouting missions, and you could deploy the robots off the side of the vehicle, go out and do this scouting, gather a lot of information, and then just make better, more well-informed decisions.
So one of my first days at Axios, Mike Allen sent me a photo on Slack, and it just said, like, what is this? And it was a photo of a Chinese robot dog, and I wrote about it. It's interesting. It's cool. It has security concerns. How are you thinking through competition with other countries, other militaries, and why would you say this vision is the standout?
Yeah, amazing how that works. I've been interested in legged robots and doing research in this area for over 10 years, and it's really been the last few years that you've kind of seen all these companies pop up and with legged robots recently. The difference, I think, is really in the approach. So myself and my co-founder, Avik Dey, we had differentiated technology right from the beginning. I showed you kind of pushing the robot. It seems like it's compliant, moving a lot of the complexity from the hardware into the software. That's part of our PhD research. But then what we did is we started really iterating with customers. So our first customer was Navy Special Warfare, where they trained the Navy SEALs. And we went out, we had a really early prototype. My background as an engineer, you kind of have to swallow your pride when you're bringing a very early prototype out to do a demonstration and kind of integration event with Navy SEALs. They could be very harsh on things, and it wasn't really a finished product at that point in time. But by going through that and actually working with them to figure out, what are the real challenges? What does this system need to be? It's not designed by a bunch of engineers sitting in a room. It's designed by this really tight interactive loop with the customer. So that really set us apart, and that's why we're the class leader in terms of building a ruggedized platform. So the robot is fully sealed to IP67. That means that you could actually submerge the robot in 1 meter of water for 30 minutes. You could take it out and it would keep going. We designed in a class-leading endurance that I talked about, 3 hours continuous walk time. Another feature as well, we made the robot field repairable. That's not something that you would think about just a bunch of engineers trying to build a robot. You wouldn't make it modular and think about that field
if a leg falls off, can you just pop one back on?
Exactly, yeah. Okay. So there's 4 bolts and there's a connector. So very simple tools. In a fielded environment, I can swap legs in under 5 minutes. It's very simplified. And so it's these kind of working directly with the customer, we were able to have these insights that I think set apart our product from our competitors. And
so vision was used at the Air Force's ABMS trials, I know that, but where else and what have you learned from those other events?
Yeah, so we've been scaling up quite a bit with the U.S. Air Force. We were deployed at many different bases concurrently, doing, as I mentioned, that basically base security. So at the front and back of the robot, we have GPS sensors. Our team put a lot of effort into basically having the robot do perimeter security autonomously, so the robots would get out of what we called a doghouse, walk around the perimeter.
He's woken up.
And the sensors would all be on and monitoring. So there's cameras at the front, there's microphones, and with those sensors, we're able to, and the computer that's inside the robot, we're able to detect, are there any sources of danger? Are there people where there shouldn't be people? Are there the sounds of broken glass or yelling or anything like that? And basically establish that secure perimeter. So that's been very helpful to inform, how do we turn this from a product into something that's a solution that's really solving very difficult problems in real world environments.
Last question of the night goes to you. Have you ever worked with real animals?
Yeah, yes, I have. So when I was a teenager in Ireland, I think I was 13 or 14, spent the summer there with some of my relatives on my dad's side. And I was very interested in animals. My uncle was a vet, and so I actually assisted him as he was a veterinarian doing surgeries on small animals, dogs and cats. And I have no idea why this was all allowed to happen. I think only in Ireland. Here's a kid. Oh, he's going to come help with your dog's spay.
Bring your son. Fine. Bring your son to work day. Yeah.
So I, very much kind of life-shaping experience. I did not want to be a veterinarian. That wasn't the conclusion. But I've always been fascinated by animals and technology, and that's exactly what we have here.
Well, Gavin, thank you for your time and showing us man's new best friend. To our audience, thank you for being here. Thanks for sitting through all this and sticking with us. Please grab a refreshment, stick around and network, come grill me with your tough questions, meet the team, we'd love to say what's up. And make sure to hit the petting zoo upstairs. That is a hell of a petting zoo up there. So thank you again, guys. Thank you.